Now we are going to do introduction to AC circuits, part 2. Still it happens to be a class of introduction to AC circuits and not AC circuits proper, because we are still doing the mathematical treatment. Mathematical treatment of the simple harmonic variation. Of I at t and E at t in AC circuits. So it is still happening to be the introduction to that, and today we will do the mathematical treatment. Now coming to this, the main essential simple harmonic equation will be I at t equal to I naught sine omega t. Let us say take the sine function. This is a simple harmonic variation function, where this is the trigonometric sign will tell you that it is varying sinusoidally with time. Now here, supposing instead of omega t, I write it as phi itself. In that case, I can be represented as a function of phi, will be equal to I naught sine of phi. So I as a function of phi varies as I naught sine of phi. Now how does this vary? We will now proceed further. The phi can vary between phi equal to 0 and phi equal to 2 pi. This whole interval of 0 to 2 pi in the terms of the values of pi can be divided into equal stepping up of values for phi, as say 1 is phi 0, next is pi by 4 more, next is another pi by 4 more, and so on, or pi by 8, another pi by 8, and so on. So you can either increase in steps of pi by 8 or pi by 4 or pi by 2, as may be the case. But in order to have a variety of all phases, at the same time not going deeply into many subdivisions or stepping ups, I will take the step up value as pi by 4. Now let us see how the sine value varies with this. This will be our next study. Now coming to this, you find, now there I will draw a tabular column. I as a function of phi is equal to I naught sine phi. It is a sine function. Now how am I going to change? Now in the case when phi equal to 0, sin phi equal to 0 implies I as a function of phi is also equal to 0. Then when phi equals pi by 4, sin phi will be equal to 1 by root 2 implies I at phi will be equal to plus I naught by root 2, and sin phi will be plus 1 by root 2, and so I naught by root 2. The third case, when phi equal to pi by 4 plus another pi by 4 will be pi by 2. In that case, sin phi becomes plus 1, more than 1 by root 2. So this implies I as a function of phi will be equal to plus I naught. Then the fourth one, when phi equals a pi by 2 plus another pi by 4 will be 3 pi by 4. Sin phi will be, the phi will be in the second quadrant because it is less than phi, it is 3/4 of pi. Sine value in the second quadrant continues to be positive, and so this will be equal to 1 by root 2. Because sine 3 pi by 4 is sine of pi minus pi by 4, which is sine of pi by 4, which is 1 by root 2. That implies I as a function of phi is equal to I naught by root 2 with a positive sign. Next, phi will be when phi equal to 3 pi by 4 plus another pi by 4 will be pi, which means sine phi will be equal to 0, which implies I as a function of phi as a function of phi will become equal to 0. So this is what we have seen for the range between 0 to pi. Then we will go on from pi to 2 pi. Now if you observe this, all these values, you find that all of them are positive. All of them are positive, and then the value increase from 0 to plus I naught, and then decreases from plus I naught to 0 is what we saw. So this is what is happening in the case of as phi varies. Now it is the 0 to I naught. How does it vary? It varies from 0 to I naught as phi increases from 0 to pi by 2. And then when does it decrease from I naught to 0? As phi increases from pi by 2 to pi, you find that it starts decreasing. This is the first part of the whole thing. Then we will give the increment from phi equal to phi to phi equal to 2 pi will be our next attempt. Next will be so phi varies from phi equal to pi to phi equal to 2 pi. Now what happens? Now when phi equal to pi implies sine phi equal to 0. That's what we saw even in the previous one, where it was the terminal point for pi 0. That implies I as a function of phi is equal to 0. This was, I am repeating, 1, 2, 3, phi 0, pi by 4, pi by 2. The third one is pi. First one is 0. Second one is pi by 4. Third one is pi by 2. And the fourth one is 3 pi by 4. And the fifth one, this is the fifth one. I am continuing from the previous one. The end of this fifth one is the beginning of this study, equal to this. Then sixth one, you have to add one more pi. Therefore, when phi is equal to 5 pi by 4, it implies sine phi is equal to 5 pi by 4 will be equal to sine of pi plus pi by 4. That means it goes to the third quadrant where sine will be reciprocal. It will be minus sine of pi by 4 equal to minus 1 by root 2. So that again implies I as a function of phi for phi equal to 5 pi by 4 will be minus I naught by root 2. So it is from 0, it is just going down to a minus of I naught by root 2. This is the sixth. The seventh one will be when phi is equal to 5 pi by 4, 3 pi by 2. If you add another pi by 4, step up pi by 4 with respect to 5 pi by 4, it will become 3 pi by 2. That implies sine of 3 pi by 2 equal to 1, minus 1. And therefore that implies again I as a function of phi will be equal to minus I naught. Maximum negative. This is 7th. The case of 8th, I wanted to have all of them at the same in this thing. So I'll go to 8th. I'll write my 8th here, or you can just copy this. Now you can just have it in your notebook so that even if I erase this, you will still have in your notebook and we can have a comparative study. Note that all these are negative. Negative values. So now between phi equal to pi and phi equal to 3 pi by 2, the negative value of I as a function of phi increases. That is, becomes more negative. Now let us see what happens beyond this 3 pi by 2. As phi increases from phi equals 3 pi by 2 to phi equals 2 pi, what happens? Now I will recall this, whatever we have done. Now if phi equal to 3 pi by 2, this implies sine of 3 pi by 2 equal to minus 1. That again implies I as a function of phi for phi equal to 3 pi by 2 becomes minus I naught, maximum negative. That was probably number 7. Then 8th will be phi equal to 3 pi by 4, 2 plus another pi by 4 will make it 7 pi by 4. That implies sine of 7 pi by 2 equals sine of 2 pi minus pi by 4. This will be in the 4th quadrant. Still it will be negative, minus sine of pi by 4 equal to minus 1 by root 2. So that implies I as a function of phi for phi equal to 7 pi by 4 will now become minus I naught by root 2. So it continues to be negative 8th. So it continues to be negative now between phi equal to 3 pi by 2 and perhaps phi equal to 2 pi. I don't have place here, I will write it after I finish this. You find that where the modulus of I as a function of phi will go on decreasing. That is, I at a function of phi becomes less negative and reaches 0 value at phi equals 2 pi is what we are going to see. So the last one, we have already seen the last one, when phi equal to 7 pi by 4 we have already finished. 8 pi by 4 is 2 pi. 2 pi implies sine of phi will be equal to 0, implies I as a function of phi equal to 2 pi equal to 0. So now that we have got all these values, we will just draw the tabulation for all the 8 of them, as I am going to show you now. Here a complete tabular column will have serial number. Now phi equal to omega t, then I as a function of phi equal to I at omega t, serial number. You will have 9 entries: 1, 2, 3, 4, 5, 6, 7, 8 and 9. First is 0, phi equal to 0, and this will be 0. The function is I equal to I naught sine of omega t, or that is I as a function of t. I as a function of phi equal to I naught sine of phi. Now here second one will be pi by 4. This will be I naught plus I naught by root 2. The third one will be, after pi by 4 it is pi by 2 plus I naught. The fourth one will be, after pi by 2 it will be 3 pi by 4, for which this will be again I naught by root 2. The fifth one will be, after 3 pi by 4 it will be pi. It will be pi, and that will be once again 0. And then the second one will be, after pi it will be 5 pi by 4. This will be minus I naught by root 2. The seventh one, after 1 will be 3 pi by 2, which means minus I naught. The eighth one will be 3 pi by 4 will be 1 1/2, 1 3/4. 7 pi by 4, for which it will be minus I naught by root 2. The ninth one will be 8 pi by 4 or 2 pi, for which I naught will be equal to 0. So it starts from 0, goes on increasing to I naught by root 2, then further to I naught, which is the amplitude value. This is amplitude value, positive amplitude. My plus I naught by root 2 is positive, but 1 by root 2 of I naught less than amplitude. This is absolutely 0. This will be negative value. Minus I naught also negative. This is, all these are negative. This is 0. This is positive. Here you find that in all of these the value is positive. In all of these the value is negative. That is one basically the thing. Here, as far as the entry 2 is concerned, look at this. Entry 2, if you consider, it is plus I naught by root 2. For entry 4 also, entry 4 also, it is I naught by root 2. So comparing these two ticks, you feel as if they are in the same phase. But if you watch carefully, you will find, that at beyond 2, for the third serial number, it shows an increasing trend. It shows an increasing trend. Now beyond 4 and beyond 4 and if you go up to this shows a decreasing trend. This shows a decreasing trend. So this shows an increasing trend and this shows a decreasing trend, and therefore the phase at here is not identical with the phase there, because the two things are matching, namely the magnitude of the instantaneous current is I naught by root 2 in both the cases. That way it is okay. Both are positive, that way also it is okay. But as far as the tendency for further variation to continue, if you watch and look into that, you will find that this shows an increasing trend, whereas in the other part it shows a decreasing trend. So they are not in the same phase. Same way, if you take the case of, I'll show it with green, the 6th serial number and also the 8th serial number. Both are showing minus I naught by root 2, and this also is minus I naught by root 2, no doubt about that. Both are taking negative value and both have a magnitude of I naught by root 2. All the same, you find that between I naught by root 2 and I naught, this is going to be, the modulus is going to become more negative. Whereas here it becomes, from I naught it has decreased, it shows a tendency for less negative. In other words, the modulus here shows an increasing trend, the moduli here show a decreasing trend, therefore these both are out of phase by some quantity. Now, this is what you should know. So this is the complete picture of how it varies as you vary that phi in terms of steps of pi by 4. Now coming to, this is as far as this is concerned, it's okay. Now if you are given, how are you going to convert t into omega t? This alone I'll tell you. T into omega t. Now for this, you take, if t is equal to t and omega t, omega equal to 2 pi by capital T. So if you go into steps of fractions of capital T, how will you get how will omega t change is our question. So omega t is equal to 2 pi into t by capital T. So that if t is some fractional part of t, depending upon that your omega t will vary. How will it vary will be our next study, and with that we will stop. And tomorrow the next session will be taking the cos function, how that also varies sinusoidally with respect to time. Now here I am going to convert the time instant into omega t. How does this vary? In steps, as t varies from 0 to capital T, t varies from 0 to capital T in steps of t by 8. Omega t will vary from 0 to 2 pi in steps of pi by 4. So first is 0. For that, if this is 0, here you will get also 0. Omega t is also 0. Next one, so this is the first one. Second one, if t equal to t by 8, this will become, if small t becomes t by 8, this will be pi by 4, because 2 pi by capital T into t by 8 will make it pi by 4. Then 3, if it is 2t by 8 or t by 4, this will become pi by 2. Fourth one, if t equal to t by 3t by 8, this will become 3 pi by 4. If this becomes t by 2, this becomes pi. And then here t, I am continuing here, t, and this one will be omega t. Now t after t by 2, it is 4t by 8, and then 5t by 8. This will become 5 pi by 4. And then after 5t by 8 will be 6t by 8 or 3t by 4. This is 3 pi by 2. And then after this 3t by 4, it will be full t. 60 by 8. 60 by 8, 70 by 8. 70 by 8, this will become 7 pi by 4. And then 8t by 8 will be t, and this will be 2 pi. Here, as when t is small t equal to 0, omega t is also 0. When small t equal to t by 8, omega t becomes pi by 4. When small t equal to this will be 6, this will be 7, t by 2 is 4t by 8, 5t by 8, 6t by 8, 7t by 8. Okay, this will be 7th serial number, this will be 8th, and this will be 9th. As usual, there will be 9 entries. Now for t equal to 0, small t equal to 0, omega t is also 0. T by 8, omega t will be pi by 4. For t by 4, it will become pi by 2. So here you are stepping up by the difference between the two successive serial numbers is t by 8. And here the difference in the omega t value will be pi by 4. Therefore, t by 8 corresponds to a phase difference, time interval of t by 8 corresponds to a phase interval of pi by 4. So t by 4 will be pi by 2 is what you should know, and t will be equal to 2 pi. Okay, 2 pi. So here 1t by 2, 2t by 2, 1t by 8, then 2t by 8 is t by 4. This is also equal to 2t by 8. This is all 3t by 8. This is also equal to 4t by 8. And this is 5t by 8. This is also equal to 6t by 8. And this is 7t by 8. This is also equal to 8t by 8. Now here, this is pi by 4. This will be pi by 2. 3 pi by 4 and then pi. This will be pi plus pi by 4, which is 5 pi by 4. 3 pi by 2. 7 pi by 4 and then 8 pi, 2 pi. So this is the variation in this. I think that will stop now for the session, and tomorrow we will take up this and then once again summarize in a better manner. Thank you.